the cloud. Okay, this is an exciting recitation. It's on AI that's been building for decades, but it's changing everything. And so we've got a great group, 30 minutes from Crail on embedded, and then 30 minutes from Olivia and Vald on design. Take it away, Crail.
Okay, thanks, Neil, and thanks everybody to join this meeting today. So my name is Crail, and from C Studio as well. So as a starter, actually, I do notice actually there are a lot of like Fab Academy students who are using the serial shell as their first tiny machine learning stuff. So this is actually the latest published article from Science. I would like to also share those kind of link in the chat window. And what actually it's about is there's actually the article is talking about the cutting AI down to size based on shell. Because in the currently model well, you can saw a lot of like artificial intelligence model as very powerful and also very expensive that you need to deploy very struggling to on some kind of like hardware devices. This is article actually is shows up how tiny machine learning works right now and how like large language models that you can works. So this is several the details here in this article. So this is actually really a like brand new like article to show that how we can use embedded programs such as embedded devices such as $5, $6 like hardware to build your own like AI models by yourself. This is the starter from my presentation. So I would like to go to directly to my news here right now. Wait a moment. So let's go to the topic here about what is like embedded AI and machine learning. And this is actually the content that we are also co-generate with by our Fab Labs, which is Trifle Makerspace. So at the beginning, I would like to have a structure this is actually the hands-on workshop as well, and you can also following those kind of details by yourself and using your on hands shell as well to try on how the tiny machine learning concept and how you can use and choose your toolkit, and also you can do some hands-on practice, and also to try to design the solution by yourself. So let's go to the first part. And this is actually also the topic coming from Olivia as well, and also the Fab Academy before, how to make almost anything and almost without making anything. So this is actually the idea, the reason why we build those kind of a topic here. So this is actually the structure about the hardware right now. So if you look at the current hardware ecosystem about edge AI devices, it's gonna be have divided into those kind of like three different parts. So the first part we can call them edge AI. It's very close to our own world, like currently TV remoter or smart speaker or smart microphone, something like this. This is very easy to get very easy to get access on it. For example, got a lot of devices they can use this. But tiny machine learning stuff, like tiny ML stuff, is part of the edge AI stuff. It's only concerned. It's only like limited on the ultra low power devices and the sensors. And beyond this, they have intelligent devices and gateways. I think everybody have the home pad, like Apple home pad or like smart speaker in your home, and each of the devices such as gateway to communicate with Zigbee, Wi-Fi, or Bluetooth, and with different like home automation, or home assistant, such kind of like sensors. And beyond this is also we call them like cloud AI. Cloud AI is a little bit far away from our society right now. I mean, our other people's living right now. Normally, the big companies such as Amazon, Microsoft, Azure, and they buy those kind of like big like devices to do the cloud AI, like server stuff. This is actually the main difference structures from edge AI to cloud AI. If you go to the next part, and so oh wait, so this is actually how actually the hardware looks like. So if you go to the Raspberry Pi, such kind of stuff, if we dive into the all edge AI products. Start from microcontrollers, MCU boards, and also you can go the thinkable computer, which is high powered CPU or some kind of like AI performance chips, such as FPGA or any other chips here. And also you can go to the high performance thinkable computer, such as GPU, right? The NVIDIA Jetson stuff, you can do the edge AI stuff like this. So tiny machine learning actually is a really, really beginning of edge AI devices, which is mostly focused on the like microcontroller, which you can very familiar with, microchip and expressive and some other like Nordic, such kind of things. So this is actually the most like popular product that I mean the boards that we introduced here. How you can use like less than $10 to build your own like tiny machine learning model by yourself. And if you go to the structure about the the machine learning stuff and system, edge machine learning is a really a beginning of those kind of things. You can do some like interfaces with the sensors, with the human interactions, and do some processing in itself, and the data to the tiny machine learning level and cloud machine learning level or the mobile machine learning level. So based on the application levels, actually you can solve from here. It's also have a different like levels applications. For example, the edge machine learning will normally built in devices. A TinyML is sometimes you can build in the sensors or built in on some like data collection devices. And cloud machine learning is only by the server level. And mobile machine learning is such kind of thing like mobile like applications. If it looks like this. So these have a four different like applications level that you can go from the system about machine learning. So how actually the edge AI computing means to life and how the technology train and opportunities. So what actually we can thought right now, the raising of edge AI computing stuff is very like popular right now. And you can saw a lot of like smart home devices, smart city, variable devices as well. And also you can have a lot of like Toolchains and sources that you can use, and you get more like complicated like large language models and hardware integrations to start it. So beyond before that, maybe people always try to use Raspberry Pi or other product to start their own like AI TensorFlow like models, but right now NVIDIA Jetson have much more powerful edge computing like edge AI devices, so you can deploy much more like complicated like vision on it and the mission on it. This is actually the core value for tiny machine learning stuff. So think about this. Actually, the machine learning and applications is only actually for the microcontrollers. This is the key things that you can do. So everything machine learning applications once it's deployed on only deployed on the microcontrollers, which will be beyond belong to tiny machine learning stuff. And also everything with low power consumption, the variable like devices, something like this will be also be belong to the tiny machine learning stuff. And the implementation method of edge intelligence, if you want to only like deploy your AI model offline on the edge side, this is also the core value for the tiny machine learning. So everything you can solve from here will be the key features that you can get know from this. Low power consumption, small devices, and local processing is the key things, key features for tiny machine learning right now. And this actually got a lot of like applications as well for tiny machine learning, such as machine vision applications and sound and vibration sensors, same things, and the motion, the posture recognition in the tiny machine learning stuff and area. So also the second phrase that we go to the Toolchain through platform. And there got a lot of like platform as well right now in the market that you can start to choose by yourself. So for example, the TensorFlow Lite, that you can use the TensorFlow to program your MCU controller, and also by Python as well. And the PyTorch mobile, the application that Torch is also can use this. Agent Pulse is also one of the tool chains that actually we introduced before in last the Fab Academy, and also some of the student has me try to integrate some of the AI model and training the data model by themselves. If you're using STM32 and ESP32, also get them on like Cube AI like a platform so that you can training capture your data by yourself and the training a model online and offline by yourself as well. And also CD is also have the Syscraft AI that you can have the on devices like model also online training your model by yourself is very in the very quickly and very easy way to start it. So this is a several like resources as well. And if you want to learn more ideas about tiny machine learning, we got some like books recommendations here, and also the AI at the age, and also the machine learning like a system like a curriculum from professor. And this is some of the brief like tiny machine learning projects how we made it, how that this works, and this is such a part of the like contents before. And we are trying to use a shell board to do some object detection, and this is actually how the steps. The first you're gonna be use Arduino IDE to collect the data, and then you can use Agent Pulse to do the image annotations and data set balancing and training and model design. Then you have testing and validations. You're gonna be spending like several hours to start it to try to get use those kind of platform. Then after you're training and testing your model very well, you can deploy and download those kind of like zip files as a library in your hardware devices. This is actually the several steps and teach you how you can go to the tiny machine learning step by step. And if any of the students very interested on it, you can also recognize those kind of like link to start it by yourself. And this is a summer like Agent Pulse like workshops that we have made before for the Shenzhen University students as well, and people start to use Agent Pulse to build their own like tiny machine learning like models by the hands-on like microcontroller boards. This is other objects that we can start it. So this is actually the shell boards, and which is very popular, and people can use this very easily. Nordic one, and also we have a platform as a SenseCraft AI. It's actually the new platform that we release and keep updating a lot since from last like 6 months. And last like graduated ceremony from Mexico, I think more than 6 months, 8 months. So the platform actually we are doing is the reason why we are making this because sometimes we found it for the beginners it's going to be too complicated for students to learn, and the people is the student is very struggling to making their own like boards and own like AI models. So what actually the topic here is we want to build those kind of zero code model deployment like platform so people can just use drag and drop to learn how the AI model is running on it and how you can use the AI model to capture and build something project by yourself. This is actually the value, actually the reason why we build this kind of things. The second thing is actually we want to do a lot of online model training because sometimes you do it offline. uh, it's really it's gonna be have you need to download the software and install it in your local computer, and will be also the consumer of the of your computers as well. And also you want to do more like flexible inference output as well. And this is actually how we made it and how that this works. And code free control by the shell ESP32 as well. And how use the camera to capture the face and also to show some result by the no code version and light up the LED, the project how does it works. So we have some. This is actually the website looks like and how we can make it. It's very easy. It's very easy to start it. Just name your. This is the first step that you can name your like AI model by yourself, or you can deploy and download the ready to use the face detection models and just deploy on your on your models. And this is also how the images classification example means. And if you do images classifications, they can only give you what is the images scheme is from, but they cannot do the object detections. So they can only give you one result from different images, yes or no. What is a cat or is a dog, like this. But if you want to do some much more like comprehensive like details like detection, you need to go to different model, which is actually the object detection, which we goes from this. So how does this works and why we're going to use those kind of image classifications here? So from image classification, normally people can be use this kind of for the material and the tool management. For example, in the production and the product line area, people want to use AI model to do the fast classification. Is this a screw or this is a pepper or the scissor? What is this, like resistors or capacitors or diodes? It's very quick and very fast. Just give the result. What is this? Is this the resistor or not? It's very easy to give those kind of like classifications. This is one of the like applications here, and also some of the, for example, if you want to do the like 3D printer materials identifications, you can all by different like temperatures. You can also use those kind of pictures to classify what is the situation here and what is the difference to give you those kind of classification missions. And also some of the quality control and the safeties, for example, in the PCB manufacturing and the defect detection, they got a lot of area that you can use those kind of like images and AI model to training to know what is the result happens. Is a short circuit or is open circuit? And also some laser cutting, animated detections, and the equipment automation status monitoring, and also 3D printer like quality monitoring like this. They got a lot of application that you can use image classifications, right? And also the environment and safety monitoring as well. If if you can detect whether if their person happens shows up here or not. Oh, this is this a working area was occupied is occupied or not. This is several of the simple like application that you can use image classification like model to start with, and some of the education applications as well for students. It's also very easy to use this. I think people after this kind of like instruction, you can start to do the start those kind of things as well. And the odd result, you can also go to MQTT and GPL control and the serial port by the SenseCraft AI platform as well. It's very easy to get started. So GPL control, this is some of the like very like easy like demo to shows up. This is actually what actually we are. I'm also showing those kind of like workshop in in Peru in January when I was in the Peru for Fab Lab Bootcamp. So people can just light up an LED to shows out what is if the people shows up if the face shows up here and they will light up the LED. It's very simple and easy to recognize your face and to give some feedback by the GPL. All this kind of demo can be no code. It's also very easy. And student also you can generate your model and build your circuit board by yourself to control the fan like model like speakers as well. And MQTT is very like also common things you can do the remote controlling stuff, which is also beyond belong to the like communication like class in the future, right? And this is several of the data set here, and you can do the data images here. You can also do the UART, control accuracy as well, and SPI as well. And this is a several like hands up. So if anybody, if you want to try to hands up to follow those kind of training by yourself later, you can just follow those kind of like follow my slides later, and we have a hands on like in practice like parts. Then you can build those kind of stuff by yourself and step by step following on my slides. And this is also some of the like tiny machine learning applications I would like to introduce here. Some of people to do the gesture in robotics like applications as well, and smart voice assistants, because you can also train your model by voice as well for yourself to do some voice interaction solutions. And this is also one of the a demo to show the bird detection. What is a bird? A bird comes out. What is this? And it's also squeeze like ULO 5 like models. This is one of the projects by the like communities. And this is also one of large languages model applications. It's very like popular as well in US right now. People do use Xiaobo to build those kind of like open source like AI variable necklace to recognize, actually do the voice summary about what we are talking, who you are meeting with, and give you the meeting and conversation summary by software, and send a result and meeting summary to your platform, to your mobile as well. This is one of the popular open source projects as well in the market right now. People, you can start with this. For the Fab Academies, my students can just try to learn from this and to give more like group design and by those kind of like topics. This is at the first phrase about what we're doing and what I want to introduce here. And I would like to give more like 5 minutes to introduction to introduce actually the details here. Because tiny machine learning is also part of the age AI. It's the beginning of the AI stuff, right? Especially for the ultra low power devices and sensor. But there are also some of the devices here based on GPU and the single board computer. I would like to also have a brief introduction, but not hands-on stuff. So this is the first phrase. For some beginners, if you have nothing knowledge about AI stuff, if you want only try something new deployment, such use Arduino platform, you can use a microcontroller very easily to deploy your model by yourself. It's very easy, no code at the beginning. Try to learn what is the principle from that. If you want to have more knowledge in it, you can use agent powers or start to learn tiny like TensorFlow Lite later. But if you want to do some of the complicated like applications that like on the single board computers and GPUs or the CPUs or GPUs, you cannot like avoid of like NVIDIA Jetson as well. So this is actually the tiny machine learning started. Like you can deploy the models, vision, sound, speech sensors, and it's very fast as well, and also low power consumption, and it's very easy. It's very easy for the starters and for the beginners, and also it's very cheap, right? This is how this works. If you go to the MCU, they got a lot of MCU from Nordic, from Hymax, from Espressif. You can do from this as well, and people can just start very easily. This is some of the uh, uh, like demo that we shows here, and you do the more like, because the currently right now what actually you're using the ESP32 or Nordic is a very basic and low power consumption version. But if you want to have some more powerful like MCUs, you can do much more like complex AI models on your devices as well. This is several of the other devices that we shows up here. You can trace the people, if where they're heading to, where the route, and also some gestures by the motion like status as well. And also you can build those kind of like chat windows, like AI like voice interactions models by yourself to give them kind of tiny machine learning chat. But how actually what do the short training stuff? So in the second part, actually we call them actually the generative AI, which is very popular as well. When I was in CES last year, no, not this year, beginning of this year in January, and also in another like retail like conference in the US right now, before, they have a lot of actually the topic about like inbound AI and the generative AI as well. So generative AI will be much more stronger, which will be also the 40T like calculation abilities, and also uh, generative AI stuff actually is it's not too expensive than AI server. If you compare to the 10,000 or 100,000, those kind of devices, it's still gonna affordable. Maybe 100,000, $100 can do that like this. NVIDIA Jetson is one of the things. But how we can do the generative AI? This is actually the demo shows up what the meaning of generative AI here. Before that, AI is only tell you what shows up in the images. Is a dog or is a cat, right? Is this the PCB short circuit or the open circuit? Go give you the result from the beginning of image classification. Then you can give you object detection, what to give you more ideas and object what it shows up in these kind of devices. But why we are using those kind of high performance devices for the AI stuff? This is actually the generative AI used for. So this is demo shows up here by the Jetson NVIDIA Jetson to describe what is the shows up in the images. So this is actually the live demo and shows up to describe what the man is doing right now. What is status? So this describe the image I consider right here is a man is sitting in the room and they hands up, they thumb up, or they do the scissor gesture, and what it looks like. They can give you the really real lifetime. I mean the real lifetime live straight like images description to show up what they are saying by the machine. This is the reason why generative AI have to go to the GPU model and high performance like devices for the AGI devices right now. And what is actually middle size of this if this kind of devices it's also very popular, which called embodied AI. Because when I go to CES conference, I saw a lot of like topics and like booths is showing up what is embodied AI, which actually is a kind of a gap in the middle of tiny machine learning, tiny ML, and a generative AI. So embodied AI will be much more like human machine interfaces because they have to go to the real connections with the real world. So we might gonna be called up next generation of about human machine interfaces, or they're gonna be have more autonomous like machines, right? And this is actually some of the machine stuff so you can build by yourself, and you can use the shell also build by those kind of devices for yourself as well. And how does this looks like? So the generative AI is actually is a input for the pervasive insight of tiny machine learning devices. And tiny machine learning devices is constantly supplying the meaningful data to the generative AI devices. And if we go to the bridge together, which actually going to be have shows up embodied AI structures shows up. So this is actually the key three main like popular like keywords in the AI, actually the hardware structure right now and in the society right now in the community. So I also wish like students maybe you can also start to build those kind of like solution by yourself. And embodied AI also is a bridge about science and applications, right? So the sensor will
Um,
be not going to be standalone.
Crail, it's 9:30. Oh,
Yeah,
good. Timing is perfect.
yeah. So this is actually the brief introduction about what we are doing here and how we can start it. Maybe and hope you guys to enjoy the classes from Tiny Machine Learning.
Thank you so much for that. Go back through the chat. There are a number of questions you can help answer in the
Yeah,
chat.
yes,
And
yes.
yeah, we're on behalf of the world, we're very grateful for what Seed has been doing to make all of this accessible and open and well documented.
Mm-hmm.
Okay,
Okay, I saw. Mm-hmm.
so thank you, Crail. And now Vald and Olivia take over. And for those who are in class, for the 3D printing class, I showed the surreal teapot. And that was done by Vald. Vald and Olivia both were Fab Academy, MIT Fab class students. And then they were helped by my student Amira, who's currently traveling. So take it away, Vald and Olivia.
Okay, yeah, thank you, Neil. Thank you, Crail, for the first talk. Very interesting stuff. So yeah, we have a lot to go through. So um, yeah, the we'll talk a bit now how to use artificial intelligence to make almost anything, almost without making anything. First of all, AI has been a sort of a hot topic in the last few years, right? It's not unusual to hear people say, if you don't start using AI, you will be left behind. But the real question is, what do people actually mean when they say AI? And what has been the sort of recent innovation in AI is large language models. So most of you are probably familiar with tools like ChatGPT that has this sort of like chat-based interface. You say something, you write something, and you get something back in text. And sort of a really, really brief overview of how that works. Essentially, as you can see here on the right, you what this model does is it just predicts the next sequence of tokens or words in this case. So if you say I like cats more, then it might finish your sentence by saying then dogs. So here's just an example. You give some token in, for instance, text, and you get something out. Um, it could be give me a list of 2 cat breeds, and then the LLM will spit out a list of cat breeds with an end token to tell it, okay, to stop generating. Or if you sort of look deeper at what the large language model is actually doing, it's predicting that next token or next word um, by looking at a distribution of most probable next tokens. So in this case, you can say, if I say spaghetti is, it's most likely that the LLM would say Italian, but it might also be true that spaghetti is delicious. It's just less probable in the model and how it's been trained. So why is this important to learn about? Well, first of all, these LLMs are incredibly powerful, and as you saw with Crail, you can sort of start to integrate these either locally in your on your circuits, or you can use an API to use really powerful state-of-the-art machine learning large language models to take your ideas to the next level. And here's just a link in a tutorial video if you want to dive into how to do that. We're not really going to go into that because we have limited time. Cool. So first of all, we'll just be sharing a few ways in which you can use these APIs or large language models to do certain things. For instance, you can imagine, and here I'm just going to exit down so we can use a link. You might want to put a chatbot into your design. So here in this case, the way you typically use a large language model is you can give it some kind of system prompt of what it should do. So this is just the interface for testing your model before you start using the API. So here in this case, you could describe the LLM is a positive chatbot that helps me maintaining positivity. So that's the instructions to the large language model. And so here, I can simulate a user message saying, damn, I'm so tired. And we can see what the LLM that has been prompted to be a positive chatbot will say. Okay, it sounds like you've been putting in a lot of effort. Oh, here it keeps going. A lot of crazy things. This was my mistake. The temperature over here should be around 1 to not go super crazy and random. Um, but yeah, in this case, you can, you know, make a robot or a teddy bear, and you can sort of give it a personality by just telling it how to interact with a person. But you can do more than that as well. For instance, you can use something called retrieval augmentation generation, where you can also feed the large language model a bunch of sources of data. It could be PDFs of all the components you have available in your Fab Lab, and you can ask questions about those components. So in this case, here you can see I have again a link to a demo of this. I have created what's called an assistant here that I instructed to help me find components I can use. And then here I added a file which is really just all the electronics components that we have at MIT at our lab. And here I can just ask something like, which microprocessors do we have? And let's see what it answers. So here it's looking through all the documents, and then it's writing some of the microprocessors that we have available right now. So you can imagine you can add anything from like manuals, or perhaps you have very kind of extensive documentation on the certain things you want to do, and you want to make sure that it uses the proper documentation. So this is just a way to feed it a bunch of PDFs and have the LLM sort of look through those. All right, another thing you can do is manage parameters of your system. So here we're gonna, So here we're gonna, I hope everyone is seeing yeah, okay, great. So here you can also have a system message that tries to return a JSON. So that means a file with specific settings. So in this case, I have set that that the LLM is supposed to convert things the user is saying into sound setting parameters in smart speakers following the following format. So here it can return settings about volume, about mode, like bass boost, classical, radio, standard. And it can also choose where to play that music from, in the living room, in the bathroom, kids' room, and so forth. And so here the user can say something very broad, like, I just woke up. And then we can see that the LLM returns a JSON saying, okay, let's play at volume 30. Let's play from the radio, and let's play in the bedroom. So you can see how with what Crail showed, for instance, with using kind of the image recognition, you can combine that with this LLM to have a fully autonomous music system in your home or something like that, right? So this is really powerful. Then also you can interpret sensor data using these large language models. So in this case, I've used a system message that says, you are a personification of a tomato plant. You speak as if you are a tomato plant. You are very sarcastic. Your speech is based on sensor data. It's spoken, so keep it short. Okay, so here, you could send a real-time stream of the data from your sensors to this LLM. And in this case, the humidity level is at 100% and the brightness is 51. So let's see what it says to receiving this sensor data. Oh, fantastic. I'm practically swimming over here. Great. If we then change it to humidity level is 1% and brightness is 100. Oh, fantastic. I'm a desert under a spotlight. So this is also, a fun example of how to add maybe a personality to your plant. You can also call specific functions in your design. For instance, here I have instructed the LLM that it's a house manager, and it can do all of these kind of functions. It can turn the lights on and off. It can turn the heater on and off. It can start the toaster, play music, speak, if I wanted to say something to me. For instance, let's say someone is entering the house at 4 a.m. Let's see how it reacts to that. Okay, it chose to play music. And you can really get creative with these instructions. And then, once you have these functions, you can take these functions and then put them into custom code that says, okay, let's run this function that was returned by the LLM. I hope that makes sense. All right, you can also, I'm not going to go into this, but you could also generate code in real time. For instance, if you build a mini buggy or mini car, you can kind of, with a bunch of different sensors, you can just try to generate code in real time if you want to change the function of the system that you've built. And yeah, much more. You can also use agents, where an LLM can use a tool. I'm also not going to go into that too much because we're very under time pressure here. But uh, it's something that's really coming up right now, and yeah, you can kind of use that to, for instance, like have an LLM send a file to a 3D printer, and then once the file is done, the LLM will know, and then the LLM can take different actions, and you can create these kind of autonomous systems with an LLM that interacts with some tool in the real world. So yeah, feel free to look into this more. Also, beyond text, you can use different modalities like image and audio and feed that into it. For instance, here is an example of someone who used images to do a sort of David Attenborough uh, uh, kind of joke build.
And now, as I move around,
Here we have a remarkable specimen of Homo sapiens, distinguished by his silver circular spectacles and a mane of tousled curly locks.
All right, so yeah, so there's a lot of fun stuff to play with. And yeah, also Google has been working on, using these LLMs to control robots by simply just outputting the coordinates and rotation of the robot arms from these language models, given sort of a new image every time it image from its camera every time it finishes its movement. Yeah, there's a lot of sort of like there's open source models that exist out there that you can use. Some of them you can run locally. And then there's typically like OpenAI has, and other platforms as well have sort of APIs that perform with higher accuracy. But again, you need to run it over the internet. Great. So now with that, we are moving on to thinking about how we can make each of these classes almost obsolete using generative AI.
Yeah, so thanks, Paul. We put together some resources for how AI influences various aspects of the Fab Academy class. There are actually a bunch more resources in the slides than we have time to go over. So if you check out slides in the Fab Academy page, you can find a lot of bonus material there. Anyway, let's talk about CAD and manufacturing. So there have been several tools that claim to allow users to generate CAD models by describing them in natural language. And as you can imagine, there are currently limits to the level of complexity that we can expect from such tools, but I think it will only get better. So for instance, there's one tool at the bottom called Leo, and it looks very sophisticated, but it's not released yet. But zooming in on one of these tools, which is a free and currently available one called zoo.dev, on the next slide, you can see that I asked it to create a round stool with tapered legs, and it was able to generate a 3D file that I can just directly download pretty quickly. And that's good for what it is, but after this, I tried to ask it to generate a simple box with a lid, and it failed completely.
Oh.
So you can try playing with it yourself and see what the limits are of its ability and whether it's useful for your work. So moving on to 3D scanning and modeling, you're probably aware that 3D modeling still requires quite a lot of manual effort. And typically it requires meticulous work to build these models, vertex by vertex, to adjust the topology and to sculpt the details or even rig the characters for animation. And as you can see here, Blender requires quite a lot of skill to navigate a complex interface to refine the geometry, and this is quite skill intensive. On one hand, it allows people to have full control of the generated models, but on the other hand, it's quite a steep learning curve. So now we can use AI-powered tools to generate 3D models, either from 3D photogrammetry, which you can either provide these images or generate these images. And I also heard Neil say before that you might have seen some of these text to 3D models before in a class, and there are more resources, again, hidden in the slides. I did want to bring up two particularly user-friendly tools in the next slide. So there is something called Genie. We won't generate it now, but I screen recorded myself generating something in the next slide called Chibi Fox wearing round glasses, just to give you a sense of the kind of outputs that you can expect from the model. And then there's another tool on the next slide. This is Viscom. So it's kind of a all-in-one platform where you can sketch on the tool and then you can render and you can either generate a 3D model from your sketch or from the render. And there are some other features that I have yet to explore as well. But again, just to give you a sense, I generated a sketch from DALL-E, uploaded it, then rendered it, and here's the output. It was really quick, like under 5 minutes that I could get such a model and download it.
Okay, great. So yeah, Neil might have shown you this project in a previous class, but yeah, that's something that came out of taking the How to Make Almost Anything class, and it was really exploring how we can use generative AI beyond sort of 3D models in the computer, but making physical, very kind of heavily ornamented designs. And there's a GitHub link available if you want to sort of explore this specific process that was used in this process and use the code to generate your own designs. Here's just sort of an image of some of the physical designs that came out of this. It was using the prompts or the text to the models to generate a vase made out of body parts to really see how well it understands anatomy. Yeah, but beyond sort of just 3D printing, we with classic polyjet printing, we also try to use molds to make bread with this sort of approach, and we also try to fine tune a generative model on an artist's unique style, which is this kind of blue and white that you see here. And then from that, we generated a pillow design that was then clay 3D printed on a wasp. And then at the end of this whole process, we sort of got a clay design from this AI generated model. And it's really fun.
Right. I want to talk about Genesis a bit. This paper is actually not out yet, but you can check out the GitHub page linked in the slides. So what it claims to do is to allow users to simulate virtual environments and robot actions. It looks really cool. So for instance, a user might input something like a water droplet drops onto a beer bottle and slowly slides down along the bottle surface. And then the user provides or defines 3D models and other physics parameters. And then the system has those physics and fluids solvers to simulate the scene and take into account all the gravity and tension and material properties.
Cool. Yeah, and then when it comes to not just making things, but also learning how to build things, especially large language models are super useful for electronics design. Like first you can, use them to figure out what are some components that exist out there. How can I build my schematics? And then how can I program what I want to do? And so you probably all know that, when you have to build things, there are these huge data sheets you have to go through, and you have to find the right information and understand it correctly and all this kind of stuff. But now with large language models, you can chat with your PDFs and kind of ask them, the questions that you have, like what is the what is the highest temperature I can use this system in? What are the GPIO pins that I should use and so forth? So here's just an example GIF of me dropping a ESP32 datasheet and asking it, what are the pin definitions? And then here you can see on this website, it kind of gives me the pages that this information is on, and it gives me the answer. when I ask where I can connect a temperature sensor without specifying, what kind it is and so forth. So it's super, super useful. You can also, if you don't really understand anything about pins and so forth, you can also ask tools like ChatGPT where to connect certain things on an ESP32 and an accelerometer that exists. Again, I would be a little bit cautious with this because it might not know your specific component, but if you have no prior knowledge, it can help you get started. You can also use ChatGPT to write the code for you. I'm sure a lot of you have already tried this. Yeah, and I will hand it off to Olivia to talk about AI students.
Right. So um, you might have heard of AI agents, and briefly, they are AI that autonomously performs tasks for users. So we wanted to explore how we could create AI students as well as AI instructors for a previous run of How to Make Almost Anything. And this was inspired by a paper about simulated agents. If you're not familiar with this paper, it shows that we could add various agents to a virtual world, and we give one of these agents a task of, for example, organize a Valentine's Day party, and then it will spread the message to other agents, and then these AI will start finding, partners to bring to this party. Some might reject going to the party, and you can just see as the world evolves. So what we did was we tried to create a virtual fab
Welcome
space.
to the land of open-air fabrication, where we can make almost anything almost without making anything.
So you are one of these characters in this world. Everyone else is an AI agent, and you can walk around and you can learn about the various tools in the space. Of course, powered by some LLM in the backend, and there are AI instructors where you can ask questions to. Um, and so here you're asking something about 3D printing, and yeah, you can talk to various instructors. These are real instructors. That was the joke behind this video. But then you can see other students in the class as well, and they're also autonomously creating projects. And at the end of this, we created a website documenting some of our efforts to automate some of the week's homeworks for how to make almost anything. And you can check this out in the slides.
Welcome to the land of open-air fabrication.
Right. There we go. Okay. With any tool, there are always sort of negatives and things we have to be cautious of because they can be used and they can be for good and for bad. One big limitation of a lot of these AI models is that they are prone to inherent biases or misunderstandings in the data. In this case, you can see how the image generation model is technically correct, but this is not how we would imagine salmon swimming in the river to look like. But because the AI model has been trained on a lot of data that involves salmon in its sort of edible form, it has sort of learned to use this in other contexts as well. And so you have to be very careful with your design that and test it rigorously that it doesn't really misunderstand things and cause issues. Again, another thing we've seen is a lot of people have been sort of critiquing generative AI because these images that are made from it or text and so forth is using a lot of data that comes from other artists, and a lot of people are afraid that the generative AI will sort of replace humans. But on the other side of the discussion, there's also a lot of people that say having these generative AI tools can actually help empower people to make things even better because all of a sudden they can, they can make things instantly, and that sort of allows you to be more creative and focus less on being in the trenches and getting something working. So yeah, using large language models or generative AI makes it a lot easier to write code, produce 3D designs and so forth. But it's still up to us as humans to choose what we want to make and make sure that the things we make are beneficial and and so forth. And we also, as part of the class, tried to have an LLM complete each of the tasks. And all the ideas that it came up with was very boring. So I'm sure most people here could still outperform an LLM when it comes to creativity. But yeah, that is sort of the end of the presentation. Thank you, Neil, for inviting us. And if there are any questions, I think we have a few minutes left. But yeah, that was the presentation.
Thank you.
Great job, Olivia involved. We have 4 minutes. Any questions in the chat, or raise your hand, or if it's burning, just unmute. The slides are on the class site, and the video will be posted shortly after. Let's see.
Great.
Olivia, what will How to Make look like in 5 years?
That's a good question. Do you want to start, Olivia?
You can go.
I mean, I think How to Make, I mean, it's very exciting. And these tools are a little bit scary because now all of a sudden, like, you can just use these tools almost immediately and kind of um, almost fabricate anything you want without learning. You don't need to necessarily learn how to do 3D modeling if you just want to get, an easy design. You don't need to know how to program in order to make a circuit design do what you want. Um, but I will say that from my experience, even if these models get so good that you could just immediately get instructions for how to put things together, and get the code and upload it without doing anything, you still need to know the language of the things you're trying to do. Um, so often I worked with artists, specifically on the 3D generation design. And I noticed that people who are novices, they don't have the vocabulary to make interesting 3D designs. Whereas if you work with someone who has a background in architecture, they don't just call something a vase. They have this whole language around different types of vases and different sort of patterns and structures and so forth. And I think that this will be very important moving forward, um, using these generative models.
Yeah, just quickly, I think it will be a lot easier to learn a new thing, but you still need to put in a lot of human effort to be able to understand how to create something excellent. And there will be a lot more emphasis as well on human creativity and the why, and not just like the what.
Yeah, no, those are great answers about literacy. And it's important to see this in the history of the class. It was a huge discussion when we moved beyond assembly language to these high-level languages where you didn't need to understand the opcodes. And now, of course, that's historical, and we don't even think about that. And we've been through a number of those generations. I suspect on the far side, this will feel like that. Vicky, question?
Yeah, more of a, I guess, a thought of how the future of AI and the aspect of teaching or letting people know the environmental effects that AI has on, our environment as a whole. And also, I do find it very helpful in like helping get started and if you're stuck in a place, but the fact that AI does steal a lot of art and it's not the fact that it's replacing people, but actually like stealing their work and stealing their style, and it's not being done ethically.
Uh, Let me respond to the first part of that. The current AI use is outrageous, but not fundamental. One of the projects in my lab is working on zeptajoule superconducting electronics that's a factor of 1,000 more efficient. And the science article Crail showed is about moving AI into low power, small edge systems. And so the insane power consumption today, I think, is going to be a historical aberration. There's a lot happening to fix that. On the second point, though, your point's really well taken that Olivia, you didn't really talk much about lawsuits, copyright infringement, stealing work, who gets trained on what. A very sensitive, huge topic.
Yeah. Yeah. Most of the people who are making these models, they don't tell people where they got their data from. So yes. And there's this, now people call it data scarcity, that, you know, we see that the more data you feed to these models, the smarter they get. But now we've used all of the data that is available, and now we're running into issues there. So yeah,
Because
on
in
point.
particular, a lot of the sources that produce the training data are atrophying because people are using AI and the training data isn't being produced. Something I think that's going to help with the theft is there's a lot of lawsuits right now. There was an explosion of, run fast and break things that's leading to lots of lawsuits. And I think legal liability is going to start to create a new literacy where you have to recognize your data sources.
Yeah, I just thought, like to explore that. I know it's like a huge topic and a huge bubble, but I teach kids a lot in our space, and I really try to emphasize like when you're using it, how to be mindful of that. And I mean, it's hard because sometimes you're asking and you don't know what is taken or not taken from people, but I try to be very open with them of like, if you're going to be using this, be very mindful of other people's work and how it's being used. So
That's great. That very well taken comment. Okay, we could spend hours on this, and we'll spend hours through the cycle. Thank you, Crail, Vald, and Olivia for doing such a great, concise snapshot. So have fun playing with all the tools, and see you in class on Wednesday. Bye-bye.
Auf
Bye
Wiedersehen.
bye.
bye.
Bye bye.
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 Bye. Bye.